All right, good morning, Josh and Alana. So today we're going to move on to a little quick review of exponents, as you can see. Sorry I didn't give you an assignment last time, which is Monday. I have no idea what happened, but there you go, you got a day off. So here we go. So all of this stuff you already know, so we're just going to go through it really quickly. And yeah, and as you can see at the very end, I was going to add some more stuff, and I thought, well, let's not get carried away. Okay, so first, let's do some whole bunch of evaluating here with some exponents. So when we have 3 to the 4th power, well, what does that mean? Well, that of course means 3 times 3 times 3 times 3, right? 4 times, right? 3 to the 4th means there are 4 3's being multiplied together. And we can figure out what that is without a calculator, because we can break this into smaller parts. So the first 3 times 3, of course, is 9. And the second 3 times 3 is, well, also 9. And when we multiply those two guys together, we get 81. So 3 to the 4th power means 3 times 3 times 3 times 3, which is 81. Okay, so let's do this one here. This is probably the easiest problem on the whole lesson today. 6 to the 0 power is the same as anything else to the 0 power. It's 1. The rule is anything to the 0 power is 1. Anything to the 0 power to the 0 power is 1. 1 million to the 0 power, still 1. All right, so this one is a little bit tricky, but not terribly tricky. So this is 7 times 8 to the 0. So if we remember order of operations, PEMDAS, tells us that we have to do the exponent first. So we're going to do 8 to the 0 first, and of course 8 to the 0 is 1. And 1 times 7 is 7. So just remember to do the order of operations and 8 to the 0 first, then multiply. So don't do 7 times 8, which is 56, and then go to the 0. And then you'd say 56 to the 0, that's 1. But that's not the case here. Exponent first, then multiply. Order of operations. All right. So anytime we have a negative exponent, or a number or a variable, but a number in this case, raised to a negative exponent, the rule is so anything to a negative power, I'm going to say negative exponent, equals 1 over that thing, in this case a number, to pos power. So that's our rule for dealing with negative exponent stuff. So anything to a negative power equals 1 over that thing to the positive power. Right? That's what it says. Anything to a negative exponent equals 1 over that thing to the positive power. So 5 to the negative 2 is the same as 1 over 5 to the positive 2. And of course, we know 5 to the positive 2 is 25, so this is 1 over 25. And hopefully this is all review. You've seen this before, and this all makes sense. Okay, so we can do the same kind of thing with a fraction, and this one looks a little complicated, but if you know this little trick, then it becomes much easier. So anytime we have a fraction to a negative exponent, that's equal to the reciprocal of the fraction to the positive. So recip and make exp as an exponent positive. That's the way we address this problem right here. So this is going to be the same as, we're going to flip the fraction, 3 over 2, and we're going to make this into a positive exponent. Right? That's what the rule says. Take the reciprocal, make the exponent positive, so flip it over, make it positive. And then we just do 3 to the 3rd power, right? We just do the power to the top and the bottom of the fraction. So we raise the top to the 3rd power, so 3 to the 3rd power is 27. Raise the bottom to the 3rd power, 2 to the 3rd power is 8. And we're done, 27 over 8. All right, laws of exponents. We have 4 of them. Actually, we kind of have 5, but I've ran out of room, so only room 4. So we have, when you multiply, add exponents. When you divide, subtract exponents. When you got a power to a power, multiply exponents. And then last we have anything with a negative exponent in a fraction moves to the opposite location and gets a positive exponent. So we're going to take a look at problems involving all four of these laws right here. So if you needed to, of course, you could stop the video, pause the video, and write those rules right down. When you multiply, add the exponents, divide, subtract the exponents. Power to power means multiply the exponents. And then when we have a fraction and we have stuff with negative exponents, it just moves to the opposite location. If it's in the numerator, it goes to the denominator. If it's in the denominator already, it moves to the numerator. Okay, so let's apply the rules we just got. So all these guys here are going to be multiplication problems. So the rule we just got was when we multiply, we add the exponents. So we got a to the third times a to the fifth. We're multiplying, so that means we add the exponents. 3 plus 5 is 8. A to the eighth. Just add the exponents. Now here things are a little bit trickier, but not much. So we do have two things with exponents, but we also got two numbers that don't have exponents. What do we do with things that don't have exponents that are being multiplied? We just multiply them. So negative 3 times 5 is negative 15. Nothing tricky there. They didn't have any exponents. We didn't have to do anything different with them. They're just the same as it always was. And now we have stuff that has exponents, so x to the fourth times x to the seventh. Add the exponents, x to the 11th. All right. And then we can also multiply with multiple variables, x's and y's. And again, we have two numbers, two coefficients, and again, we just multiply the coefficients like they are, just regular numbers. So 5 times 6, of course, is 30. And then x to the eighth times x to the third is x to the 11th. And y squared times y to the third, 3 plus 2 is 5, y to the fifth. And there we are. So that's multiplying. Dividing is the same, only instead of adding, we subtract the exponents. It's easy. So we got x to the 10th over x to the third. 10 minus 3 is 7. Easy stuff. All right, now things here are a little bit trickier because the numerator has a smaller power than the denominator. No big deal. So, I'm actually going to show you what this looks like, and then we're going to be able to see that the rule is actually really easy here. So x to the fourth just means x times x times x times x. That's what it means, 4 x's. And x to the ninth just means x times x times x, a whole bunch of times until we get to 9. Where am I at now? One more. So, of course, we know that when we divide things that are the same, they cancel off and make a 1, right? So x divided by x, that's what that line means, division. X divided by x, that's 1. X divided by x, still 1, still 1, still 1. So now on the top, we're going to have 1 times 1 times 1 times 1, or 1. And on the bottom, we're going to have, well, what do we got left over here? We got 1, 2, 3, 4, 5 x's. So we got x to the fifth. So we could write it out this way. That's kind of the long way to do this, obviously. The other way we could do this is we could, again, just subtract, right? Because we know we got a difference in the numbers of x's here. So how many, or what is the difference in the number of x's? Well, 9 minus 4 is 5. We just need to know whether the x to the fifth is in the numerator, like it was here, or in the denominator, like it is here. Well, that's easy to figure out. We just put it wherever there are the most. Right, we could think about this as being over 1, so it's a fraction, so that's in the numerator. The highest power was in the numerator, so we have the result in the numerator. Here, the highest power is in the denominator. 9 is bigger than 4, so we got stuff in the denominator. Right, 9 minus 4 is 5. There are 5 more x's in the denominator than the numerator. 5 more x's down here. So just subtract and put the variable with the exponent where there are more. X to the ninth in the denominator, that's got more, we leave it in the denominator. Okay, same trick here, only, again, we have some numbers in the front, some coefficients. That's okay. So we really have, just look at this without even looking at the variables, we got 6 over 8. Just reduce the fraction. There's nothing tricky, nothing different there at all. 3/4. Just reduce the fraction. And then here, when we don't see an exponent, of course, we know that's 1. So x to the fifth divided by x to the first. When we divide, we subtract exponents. So we get x to the fourth. And we're all done with that one. All right. And just as we had up there with multiplying, we can have multiple variables when we're dividing. And again, we're just looking at this fraction right here. So 15 over 6. And is there a number that goes into both 15 and 6? The answer, of course, is yes, and it's 3. So negative 15 divided by 3 is negative 5. 6 divided by 3 is 2. And then we just work the exponents here. So we got x to the ninth divided by x to the third. Subtract the exponents. We have 6. And because there are more in the numerator than the denominator, we put the x to the sixth in the numerator. And here we have y squared divided by y to the third. Again, we just subtract the exponents, subtract the small one from the big one. So 3 minus 2 is 1. And where do we have more y's? Well, we got more y's in the denominator, so we got y to the first. And I don't write the 1, of course, because we don't need to, in the denominator. And we're done. Okay, so now let's move on to the power to power. So when we have a power to a power, we multiply. So 3 times 4 is 12. X to the 12th. So easy, even a caveman could do it. All right, so then we can square, in this case, raised to the second power, square everything in here. So it's kind of like the distributive property. So we're going to square the 3. So 3 squared is 9. And then x to the fifth to the second. Well, power to power means multiply. So 5 times 2 is 10. And y to the seventh to the second. Again, power to power means multiply. 7 times 2 is 14. And we're done. And, well, of course, life wouldn't be right without some negative numbers. So again, we're going to raise everybody in here to the third power. So we're going to start with a negative 2 to the third power. So negative 2 to the third power means negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2, that's positive 4. And then positive 4 times negative 2 is negative 8. And then a to the 4 to the 3. 4 times 3 is 12, so we get a to the 12th. And y to the 2 to the 3 is y to the 6th. And we are done with that. Okay, so there's some of the basic rules. And then we got the idea that I talked about earlier with when we have variables that have negative exponents, we just in a fraction, we just move them from wherever they were to wherever they're not. So for example, we got x to the negative third. It's in the numerator. We want it to be positive, so we drop it into the denominator and we make it positive. So we're going to take care of that in just a minute. But before we do that, we still have 7 over 28. This is still a fraction. These are not exponents. We don't do anything tricky with them. It's just the same fractions as we've always known. So we're reducing 7 over 28. And is there a number that goes into both 7 and 28? And of course the answer is, yeah, 7 does. And 7 goes into 7 once. 7 goes into 28 4 times. And then we just start moving stuff that has negative exponents. X to the negative 3 is a variable with an exponent in the numerator, and it's got a negative exponent. So we drop it into the denominator and give it a positive exponent. Y to the fourth is a variable with a positive exponent. Therefore, it doesn't move. Only things with a negative exponents move. This one that doesn't have a negative exponent, it doesn't move. It stays on the top. And then we got z to the negative 6. This has a negative exponent. It was in the denominator. We put it in the numerator and change its power to be positive. So just move things that have negative exponents. Speaking of moving things that have negative exponents, we have here 5x to the negative fourth, but there's no fraction. Well, actually there really is. Because of course everything's over 1. So this really is a fraction. It's just kind of a hidden fraction. So we get x to the negative fourth in the numerator. We're just going to drop it into the denominator. So this is really 5 over x to the positive fourth. And we're done with that. Okay. Some problems that are just a little bit different than the ones we've been just looking at. And we'll get to some word problems and things on another day, next time. So when we evaluate 2 to the second times 2 to the third times 2 to the fourth, it might be tempting to say, well, I got 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. So then I got 8 to the whatever that is. All those powers added up, 8 to the ninth power. But that is not true, because 2 to the second power just means 2 times 2. 2 to the third power means 2 times 2 times 2. And times 2 to the fourth power means 2, 3, 4. And we just need to count up how many 2's we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So this is 2 to the ninth. Right? There were no 8's here, right? We didn't multiply 2 times 2 times 2 to get 8 to the ninth power, because look, there are no 8's. This is all 2's, so we just leave it. So again, the rule here is very simple. When we're multiplying, we just add exponents. We don't change the base at all. It just stays the same. Right? So we just add all those exponents together. 2 plus 3 is 5, plus 4 is 9, and it was always 2 all along. 2 to the ninth power. Don't multiply those bases together. So 2 to the ninth. Just add the exponents. Okay, speaking of adding exponents, these exponents look a little complicated. They're variable expressions, but that's okay. We know how to deal with variable expressions. We just collect the like terms. So we're multiplying. That means we're going to add the exponents. That means we're going to add this exponent to this exponent right here. So we're just going to add the like terms. So 2a's and 3a's make 5a's. And 1 plus 4 makes 5. Just add the exponents. Nothing tricky there at all. Okay. And here it looks like there's some trickiness. We got 7 to the fourth power. That's just a really big number. It's 49 times 49. I don't even know what that is. But it doesn't matter what it is, because anything to the 0 power is 1. We could think of it the other way too, where we have a power to a power, right? Power to power means multiply. So 4 times 0 is 0. So we have 7 to the 0, which is still 1. 2 more to do. So let's add these guys here together. So we don't have any rules about what we need to do with our exponents when we are adding, because there is no rule when we're adding. We just have an x cubed here, another x cubed here, another x cubed here, and another x cubed here, which means we have 4 x cubes. Just like these were apples, right? If we had an apple plus an apple plus an apple plus an apple, we'd have 4 apples. They wouldn't turn into anything else. They wouldn't be 4 like grapefruits or something. So, moral of the story here is don't change these things here if you're just adding them. We're just going to see how many there are. There are 4 of them. All right. And lastly, right here, we have x to the third plus x to the fourth. Well, it looks like we could kind of add these guys together. Maybe you might be thinking, okay, well, 3 plus 4 is 7, so maybe we had x to the 7 or 2x to the 7 or something like that. But the key thing here is these guys are not like terms, right? They're both x's, that's true, but this has got a power of 3, this has got a power of 4. They ain't the same. So what we cannot do here really is add them together because they're not like terms. So since they're not like terms, the answer is x cubed plus x to the fourth. There is nothing we could do about that. That's all there is to do. There is no like terms, so that is the answer. So the question is actually the answer. So there it is. Sorry the video was so long. I tried to move it along quickly. Hopefully I did. And I'll see you guys again on Monday. And yeah, be safe. It's a nice day out. Go outside. Do something outside. I'll see you guys Monday. Bye.